Morning, everybody. Welcome in. Mornings with Monkey Toe. Louis Herman Watt sitting here with Rowan Neville. It looks like we're up and running 3 minutes after 11. Excuse the tardy beginning to the day today. I promise you it wasn't Rowan's fault. It was a user error on my end, and that's okay. You might get used to a bit of that with me from time to time. So what are we doing here? Well, let me welcome you in and just set the scene briefly, because this is the first of our mornings with Monkey Toe. And essentially what we're doing here is this running a 4-part series over as many weeks, speaking with industry professionals and key players in the Monkey Toe and X-Beam stories specifically. I guess the discussion is going to be around the X-Beam and how it continues on its revolutionary kind of solution-driven path, which I know that Monkey Toe are really big on. It's finding solutions and then finding and creating a product that can better those scenarios for industry professionals. So if you're sitting there today watching along and you've got any comments or any interesting points that you'd like to hear about, drop a comment in the chat. We'll try clear those at the end. Alternatively, put them there anyway. I'll go back and I'll find them. You can get in touch with me, louishermanwatt@gmail.com, if you've got anything you'd like to hear in future episodes. But for today, well, we've got Rowan here. First up in the series, we are going across the ditch, and he is a structural engineer for Cush Consulting. You're hitting lead off today, Rowan. You're back from holiday. I hope you didn't come back specifically for Mornings with Monkey Toe. I know you're probably a busy guy. You've got lots going on, but thanks for joining us and helping to tell the story.
Yeah, no, it's my pleasure. My holiday was just a happy coincidence that ended at the right time to be back for this.
Beautiful stuff. Outstanding. Okay, well, let's not waste too much time. I feel like we've set the scene now and people just want to hear what you've got to say, not me. Let's start at the beginning with you then. As a structural engineer and your involvement with the X-Beam, what does your kind of role typically fit into the puzzle? Where does it fit into that puzzle of the X-Beam?
Yep. So I suppose my role kicks off when somebody identifies they need a platform on a new or existing structure, and it's to verify the structural capacity of the platform to carry the applied loads. That can get into the nitty gritty where say for an existing building, you might have weight limitations or limitations in the way you can attach to the building. Obviously, you want to tie into the building's bracing system wherever you can, and avoid putting forces that the building wasn't designed for into elements that weren't designed to take it.
Outstanding. Your initial reactions of the X-Beam then, and when you first kind of came across it or first worked with the product?
Yep. So I thought it was very interesting. So I suppose carbon fiber composite structures sort of sit more within the aerospace or high-end, F1 cars, that sort of thing. They haven't been widely adopted or used in structures or in civil infrastructure. So I found it interesting to work with, that being an application from these sort of ultra high-end things back to a day-to-day product. It's been technically interesting to work with based on it.
And that's so true. And look, when you say high-end things, I mean, we've all watched Drive to Survive, and we've all thought about the kind of technology that's being used in these incredible machines, and to kind of get that and bring that back to the construction sector, that is interesting. So had you spent much time thinking about fiber composites like that previously?
So I've done a little bit of study into fiber composites, and I've looked at their application for use in bridges previously. So I suppose that was fiberglass composites, to be specific. They have some advantages and some disadvantages, but I suppose using multiple materials to balance out the weaknesses of each and get an overall section which meets the design needs of the application is really cool. And I think that's what they've done with the aluminium and the carbon fiber.
Yeah, a bit unique, isn't it? So do you think it fills a niche?
I definitely think it fills a niche. So I suppose currently, if you're traditionally steel and concrete are your most common construction materials, I suppose, for this type of structure. But where you've got an existing building, you have weight limitations and using a steel platform, I suppose you take up most of your weight capacity in the platform itself, and you reduces how much equipment you can put on it. So I think probably the principal niche that these platforms fulfill is in those environments where weight is an issue. Where you're trying to get the most bang for your buck in terms of getting a platform up there that fits purpose, but doesn't require any modification to the existing building.
And is that kind of the main alternative, or the main enhancement that the X-Beam offers to the alternatives, that kind of weight aspect?
Yeah, so I suppose the weight's a fairly critical one in terms of getting more equipment on there. The less it weighs, the smaller the crane you can have to sort of lift it all up. You can prefabricate it more, whereas a steel platform you might have to have in chunks, so you've got multiple lifts as opposed to, say, 1 or 2 lifts. Another key advantage of the aluminium composite system is the durability. So aluminium itself is inherently durable. And if you do sort of bump it or scuff it or scratch it when you're installing it, that won't actually reduce it. It won't create a weak point in its corrosion protection, compared to, say, a hot tip gal, where you scratch it, you have to paint it, but it's never as good as it was when it was first done.
Yep. Okay. Excellent. Well, it looks like we've got a decent amount of people in the lobby here tuning in. And this series, Mornings with Monkey Toe, we'll get them all online as well. So if you've got people that you might find this chat interesting with Rowan Neville, make sure you get this out to them after. We're speaking with Rowan, a structural engineer. You touched on prefab and that kind of aspect of it. So it being the X-Beam being kind of put together, not on the roof. Is that something that you think industry people and professionals do find very, very useful? And why would that be?
Definitely. So if something can be prefabricated, say in the workshop, or partially prefabricated, say it comes in 3 modules on the back of a truck, you bolt that together on site, then you can lift that in one lift with the crane. So it minimizes your crane time, which is expensive, and for larger projects, you've got lots of people competing for that crane time. Mm-hmm. So it can streamline that construction and install process. You can even pre-mount the equipment, so you can go it all on the ground. You lift it up, and then you just connect it up on top. So it minimizes the amount of time or crane time required, and the amount of work done on a roof itself.
I guess one aspect people probably be asking is, what happens if does need to be something done when the product gets to the roof? One word is malleable that the X-Beam kind of seems to be associated with. Have you kind of seen scenarios, or can you imagine scenarios where having a composite that is a bit more malleable does work far better?
Yeah, definitely. So one recent project I've worked on with Monkey Toe was it was a roof platform for a TAFE facility in Victoria, and based on the construction drawings, this is the dimensions of everything. They remove the cladding, they go to put it on, and then you've got a 50 mil discrepancy between the construction drawings and what was actually built on site. So in that scenario, we were able to, based on the connection types for a lot of the X-Beam products being so screws and bolts and the like, it can be modified on site. So we were able to move those connections and adapt them to suit that 50 mil discrepancy. So they were still able to install it in the same day. There was just a little bit of backwards and forwards to make sure that we weren't reducing the capacity of anything.
And I guess that's another positive of the lack of welding, along with the hot work permits and all that sort of thing as well. What about in terms of weather tightness and actual longevity of the structure? What can you talk about as far as the X-Beam in terms of that sort of thing?
Yep. Well, so the X-Beam itself is it's all aluminium section, so it itself is inherently durable. It uses aluminium or stainless or gal bolts. You just need nylon washers to separate the materials. One key advantage of the X-Beam over, I suppose, traditional purlin mounted platforms is, say for a typical X-Beam platform, you've got 4 holes in the roof. You've got a lovely little rubber boot that fits around that and flashes it to the roof. So you've only got 4 potential points of water ingress. For a traditional purlin mounted platform, Every time it crosses a rib, you might have a tech screw going down. So you could end up with, say, 50 or 60 or 100 potential water ingress points. So it's inherently more robust in that there's less locations where you could get water leaking into the roof.
Excellent. And you've spoken already a bit about the composite and the kind of uniqueness of the carbon fiber and the aluminium. I guess one thing we talk about is steel, previously being the powerhouse, or maybe still is the powerhouse, depending who you ask. If you were doing a scouting report, Rowan, and I asked you to put them head to head, steel versus what the X-Beam composite, could you give us a couple of reasons why you think this composite is so, I guess, handy and efficient in specific scenarios?
Yep. So I suppose the X-Beam, where it shines the most is when it's being retrofitted onto an existing structure. So it weighs significantly less than the equivalent steel structure, but gives you the same or similar performance. Allowing you to mount the equipment you need without having to retrofit the existing structure with adding new columns or the like. In terms of a new build, it still has advantages in the weight. So the less something weighs, the smaller the foundations you can get away with. Particularly for New Zealand, the less something weighs, the less seismic mass you have. Which, when you get to those near fault factors and everything over there, the less weight's a lot better. The less bracing you have, and it all sort of it trickles down and makes the whole building a little bit more efficient.
Yeah, that's right. Earthquake chat. Couldn't get to. I'm actually surprised we got this far into it without having to talk about those fault lines. But that's about right. Hey, as a structural engineer and someone that kind of has this innate understanding of the X-Beam, where could you see the technology heading in the space?
Yep. Also, currently it's being used for roof-mounted platforms. However, there's no reason it couldn't be used for commercial or sort of residential structures, potentially even for bridges. So remote area bridges, say it's a halfway up a mountain or something, and somebody has to backpack all the pieces in and assemble it. You can carry it in there with a couple of people and assemble it with a drill. So remote area bridges or access bridges where you need to deploy a bridge quickly. Say the old bridge got washed away. You need something lightweight you can get in place without having to have cranes in sight and other massive pieces of infrastructure you might not be able to get there in that environment.
So the way you see it is there's a bit of literal off the beaten track thinking that you could kind of use with the X-Beam technology. And to other people that I've spoken to, and I know during the series, I think that's kind of a really similar tone and kind of aspect that we'll hear about throughout. So that's really interesting. One thing from someone who has hands-on experience, and especially in the industry, I'm sure you're around, colleagues from other companies and people that talk about this stuff a fair bit. Where do you think the missing link is from getting the X-Beam out there on all projects that could be using it? Is there something that you can think of that maybe make people hesitant, or I don't know if that's the right word necessarily, but do you know what I'm getting at?
Yeah, well, I suppose. So traditionally, steel, timber, concrete, they're the three big ones. Anything outside that, people don't have as much exposure to. They might not have seen it used on site before. And for the people doing the design or the engineers, they might not have had exposure to those codes before. So, I mean, typically, unless you use a material, you're not going to read the code because nobody needs to go to sleep that quick in the evening. Most structures are steel and concrete. So I suppose, but by increasing that exposure and highlighting the benefits in terms of constructability, time, cost, durability, that sort of thing.
Yeah, absolutely. I guess for roof mounted platforms, who sets the scope for the project? And do you think that people are starting to think more, those people in particular, and those industry professionals are starting to think more innovatively about the kind of type of innovative, I guess, product we've kind of got with the X-Beam?
Yeah, definitely. I mean, the more the product gets out there, the more it's seen, the more people become aware of it, the more they'll use it. from I suppose a project engineering perspective, if something can be done faster or more reliably, that reduces risk and construction time, which is always great because there's plenty of things that'll throw it the other way. So it's always nice to be able to, I suppose, reduce those at the front end. With that, it all depends on who's setting the project scope.
Mm-hmm.
So it could be when somebody goes, here's the project brief. It could have roof mounted platforms to be aluminium or steel, or it could be in the tender stage. The contractor could provide, yep, here's our quote for a steel platform, and here's our conforming alternative, and this is why we think it's better. So there's a number of, I suppose, entry points where the platform type can be decided.
At the end of the day, I've never met an engineer that doesn't love efficiency. That's a true statement. I swear that's something that you and rightly so, you guys think about it a lot, which is fair enough, because at the end of the day, again, one small thing can put a project out by a long way, and that's a sentiment I've heard a lot. Is there any parting wisdom you'd like to leave us with, Rowan? Anything that I haven't kind of asked you or prompted you to talk about that you might think people would be curious to know about the X-Beam?
I think we've covered most of the aspects. I suppose the X-Beam, the advantages all come down to the inherent durability, the reduction in weight. I suppose the increase in carrying capacity per kilo of platform compared to a traditional steel platform.
Yeah, well, on that exactly, we've got a comment in here from Heinz. Thank you for shooting one through. That's awesome, Heinz. How would the load capacity and deflection compare with traditional steel?
Okay, so I suppose aluminium is a bit weird. Depending on if you pull it, squash it, or twist it, it has different capacities. I suppose the key difference between aluminium and steel is the stiffness. So aluminium's significantly more flexible than steel. So to mitigate that, they use the carbon fiber composite. So in the areas that need stiffening up, they include this carbon fiber composite, and that provides a localized stiffening and a strength increase. The beauty of that is you can tune it to where it needs to be. So you don't stiffen the whole platform. You just stiffen the elements which need it, and you get similar performance to steel.
Yeah, outstanding. There you go. I think that summed it up really neatly, and appreciate that comment coming through, Heinz. We'll let Rowan shoot off and get a glass of water. I think this has been fantastic, 20 minutes or so. It's emotional stuff, mate. I know the X-Beam, it gets me going as well. Yeah, absolutely. Look, thank you for everybody, the 15 of you that sat in the lobby today. And as I said, this is going to go online, as will all of the episodes in Mornings with Monkey Toe. So share it around, spread the word. I will say thank you to you, Rowan, particularly for stepping up first in this series and giving us that brilliant hands-on kind of real life insight into how the X-Beam was, I guess, efficiently put into everyday life. We're not going to be back next Tuesday, but instead it's a Friday treat for everyone to end the working week. We'll be talking with internal product specialist Logan Klenner at Monkey Toe. Now, he is actually the developer of the X-Beam, and I know there's going to be some fantastic stuff we'll get out of that chat with Logan about, I guess, where the concept came, where he sees it heading, the progression, and all of that brilliant stuff. So thanks again for tuning into the first episode of Mornings with Monkey Toe. I've been Lou, him and Watt. We've had Rowan Neville over in Australia. He's got up a little bit early for us. No, they tell me he doesn't stop working though, so it was no drama for him. We'll be back again. And once more, thanks for tuning in. We'll catch you next time.